Hello, everyone. Welcome to DevStandup episode 20. And today our guest speaker is Joseph Haske. Joseph holds a master's actuarial and financial engineering from the University of Tartu and is a senior enterprise architect at Pipedrive. Over his 4 years there, he previously worked as a risk manager in security and as an AI use case reviewer. Today, he will discuss how coding in C language helps you truly understand the algorithms and applied maths at a deeper level. And our topic is called, If You Want to Learn, Write C. And I would like to hand over the microphone to Joseph, and we could start up the session. So, Joseph, you are.
Thanks. Yeah, that was a good introduction. So, obviously, this is a very strong statement to start off with if you want to learn write C. But it comes from, I was sitting in this GLM class, which is Generalized Linear Models, in my master's degree, and we were making models in R. I had really studied the math, so the structure of the course was you do the math part, and then you do the programming part. You make the model that you learn about. And I thought that I had a really good grasp on this topic, but it turns out it was tenuous. And I hadn't gone into the level of detail that something like writing code in C makes you do, which is why very often when I want to learn about something, and I have a practical example at the end of this, I will choose C as my programming language. But why am I even qualified to talk about this? Well, I'm a hobbyist programmer, which means that I don't write production code. So I write solely for learning. And this is also why I put knows in quotes, is because, yeah, I know C, but I wouldn't trust myself to write production code. And I think that this is one of the reasons that I think it's a great language to learn with, is because some of my practices aren't the best. I also use Arch, by the way. I just wanted to throw that in there, and it has absolutely nothing to do with the fact that my computer is more than 10 years old. But let's go ahead and take some inspiration. And this guy is Chris Sawyer, for those of you that don't know, and the game is Roller Coaster Tycoon. And this does tell my age a little bit, but this was one of my favorite games growing up. And it's written almost entirely in x86 assembly. And so if Chris can make his project in x86 assembly something that ran on machines that it should not have been able to run on because he was just so into how to optimize the code in assembly, you can use C for your projects. But why C? Why not assembly? Well, first and foremost, you can get some internet clout. You can see here, making Minecraft in 2 days with no game engine, 48 hours, C and OpenGL. And I would call this actually a little bit hardcore mode, even for me. I don't touch OpenGL. If I want to write some graphics code, I do use a library for that, SDL2. But you can see that it does get you like 5.2 million views. And one thing I think about this project is how using C, it makes you manage the scope of your hobby project, because you have to decide what do you want to learn about and include into the scope, and what can you not be bothered with that maybe you should find a creative solution to get around, which will help you learn. And the other big thing is that it's lightweight. It provides some level of abstraction, but it keeps it simple. So you can see here, normally you would return an integer, but I've said returning void is fine. And it's very common to have to include the IO header file or whatever you have in your language. But I remember like learning Java, it wasn't just printf hello world, you had to learn system.out, and system had to be capitalized, and you don't actually, like if you're following a university course, you don't actually learn why system is capitalized. You don't learn about these dots. Whereas here, okay, you have to learn about the printf, but it's the same in any language. So this will compile and it will run. And probably the biggest thing that I hear as a counter argument for that is memory management. But for most hobby projects, you can put everything on the stack. And the stack is basically just right there for you. And if you want to put things on the heap, that's when you start having to manage your memory a little bit. And so you can see here, I have used 100,000 characters for this string hello world. Most likely, actually, the compiler optimizes this down to what it should be anyway. But this will also compile and run. And so for simple projects, memory management really isn't an issue. And you can even get some performance benefit out of it as well. Like I remember I was writing my thesis code, and I wrote the code in Python, but it was like taking 15 minutes to run because it was code that you couldn't use NumPy for, which is for vectorized math. And I switched it over to C, and within like 2 runs of the code, I had back all of the time that I had spent developing. But now let's go to a practical example. And I should be able to, there we go. We'll move over to this practical example, and I'll show you that this, I'm not sure if you can see that, so maybe make it a little bigger. You can see that I have like 400 lines of code in here, 454 lines of C code. It's all in one file. And if I press Control F and I look for malloc, you'll see that there are 0 results. If I look for mmap, then there are also 0 results, which are 2 ways to put memory on the heap, which means that I'm not doing any memory management in this code at all. And so what does it look like? Well, we can see the simplicity of compiling a single header file piece of code. And it compiles. And here we have what I've been working on for the past couple weeks, which is basically a bash game engine. And so I've called the game into the bastion. I'm still working on the engine, but you can see that I am actually running bash. And I'm running this within part of the game engine, but I also have map controls, so I can move around the map just fine. And if I put a bunch of garbage text in here and move the cursor, you can see that it jumps back to where it's supposed to. And this is from a fun little piece of old technology. I think it's from like the 80s or something, ANSI escape codes. And so these allow you to do these terminal manipulations, and they're in the code here. And so like this is the escape code for resetting all the colors. So this \x1b, this is escape in hexadecimal. And then in most of the codes, you have the opening bracket, some number, and a letter, or just the letter if you're shortcutting the code. So I haven't put any coordinates in here, so it defaults to 0, 0. And so I did lie a little bit. Earlier, I said that I don't allocate anything, any sort of memory other than, well, actually I said on the heap, but I do allocate some memory. And this was an interesting thing I found here, is that in C with Linux, you can not call the system call for mount, but you can call mount from the Linux header files. And you can mount a temporary file system. So if I get a new line here and I make a new file in here, and then I can go to my file system. And I can go to this temporary directory where this is. I can go, you can see entrance here, which is where I changed rooted to, and there's nothing here, even though if I look in the game file, it says that there's stuff here. And so this is happening in memory, and it comes from another learning I had about this project. Well, C is one of those things, it drives you to come up with creative solutions, because I want to write a dungeon crawler that teaches bash commands, but I don't want to re-implement all of the bash commands. And I want the user to have a safe environment, so I have to find a way to do that. And in doing this, I found out about Linux namespaces, which is what all of this stuff is about. In order to do that, I had to figure out that, oh, actually, I need a mount namespace, which is what's going on here in this code, and how you achieve this separation. But I also had to find out about user namespaces, which presented me with another choice and made me learn about different parts of the kernel. So there's actually one, I think it's called a kernel flag, but basically if that's set to 0, this won't run because the kernel won't let you create a user namespace, which I need so that I can do the mount namespace so that you don't need to run this as root. Another interesting thing that I learned while doing this is about Linux, and it's that you can start a shell with an injection script, and this allows you to basically do stuff while bash is starting up. So I can set basically this part of the bash prompt, so I can show the working directory and then the $sign. I can set the history file, because otherwise it'll show a weird error if that file doesn't exist. I can override things. So for example, let's say I want to override change directory because I want to detect from my program that something has changed or the user's in the right directory. So I can call the built-in change directory, and then I can print a working directory to a file. And I can do the same thing for source. So I can run the built-in and then actually re-export this part, so this doesn't change. The user can't change it because I reset it basically after their command source runs. You can see some more of the ANSI escape codes. I make a lot of use of this because of the need to draw the lines, the need to draw the strings on the top, and they also make it so I don't have to redraw the whole screen every time, which was another thing that I needed to prevent. I needed to prevent the screen flickering, which comes with drawing every time. So if you're ever like writing something and you're using the terminal to do something, you can check out ANSI escape codes and they'll give you a lot of help. Now, back up at the top of the code is maybe something a little bit interesting, where, okay, I needed to store map files, some map tiles somewhere. And, okay, if I use something with classes, most likely I'm just going to opt to make it a class, and I'm going to call it good to go. But in C, there are no classes. So I can use structs, or I can just use a collection of variables that are cleverly named. And I went with a combination of the two approaches because to actually write the characters to the screen and do most of the character manipulation, it made most sense to have an array of strings, or a 2D character array in C. But with the formatting, it actually made more sense to keep it in a struct because the array wouldn't be a defined size. And if you look at these escape sequences, they're all different lengths. So you would have to basically figure out the longest one that you were possibly going to have, and then make all of them that size. But in this case, I can make them the size that they need to be, and I can just tell the game where to put the formatting. So I put the blue at position 0, 4 in this array, which is actually this one, and then when I start the next line, I can basically reset the formatting. Whereas when I go to print the strings on the screen, I can just print them if I need to. If I need to like look around them, I don't have to jump through a linked list, even though I could potentially consider that approach of just making everything in one struct and just having a linked list. And there are, I guess, two more like learnings that I had here. One was a little bit about process interaction. So basically, I had to get this for PTY running, which is basically just running another terminal inside your terminal. And I hadn't really done anything with fork in C before, so I had to learn about, okay, if it's less than 0, it actually failed. If it equals 0, that means that you're inside the child process. And so basically, the parent code and the child code both start here. You have to check if it's equal to 0 and then put the child code in this. And the parent code goes after that. So my game code goes here, and this terminal on the right is running within this if block. And so I have to do some things in order. So I need to basically send system signals back and forth. I need to unshare the user space and then set up some stuff in the proc folder, which is the process folder in Linux. And then I can call the continue signal, and then I can do the rest of the containerize, which you saw earlier. That's setting up the actual mount namespace. And we get to where we execute bash with the inject that I showed earlier. And then let me go ahead and find the last little thing in the code, which is this term iOS. And this was the last sort of piece that I needed to make this terminal run independently. And what you see here is this raw terminal, cf make raw, and this makes it so that normally when you call get char in C, you have to press enter after the character. And then you have to like flush the rest of the input, and it's kind of annoying. But when you use raw mode and you use this term iOS, you actually turn that off. So when you press a character, it will grab it right away, and it also doesn't just echo it to the screen. And so, yeah, those are basically the things I learned while working on this like 400-line project. I'm sure I missed something, but yeah, I think it's a good showcase of why you should choose C if you want to really learn about something versus some higher level language.
Yeah, that was it, right? Right?
Huh?
That was it, right?
Yeah.
Yeah. Atakan, you could start maybe if you have any questions.
Yeah. So I had a question about like is it possible to maybe, keep these like you mentioned that, hey, I'm using this mappings, but but on some of them you said like you need to have the root access or like run the program as sudo to access some of the partitions. Do you think maybe like bundling the some projects with the, there is like the kernel as a static like library projects? Do you think that will make it like more portable? So, and also like you don't need to carry the, like you can port it to anywhere because essentially like you're bringing your own kernel runner with you.
Yeah. So it will compile with other kernels. It just has to be new enough. So every time I include a part of the kernel as opposed to using part of the C library or calling through exec, I make a conscious choice that, okay, I'm making this less portable. So, for example, drawing to the screen, I could use it's either curses or ncurses. It's a library. It would make it more portable, but this is mostly about learning for me. So I've made some choices to make it a little bit less portable.
Yeah, thanks a lot. By the way, it's really kind of a bit hard to grasp because C language is something that it requires knowledge and like persistency to understand all the details. And I remember in my university time, well, we had also courses in the C. I quite enjoyed that, like in terms of like understanding the depths of the programmatic algorithms. But at the moment, we are not using that like in day-to-day work. I had a question that I know that C is powerful language and it's pretty unpopular in IT world. Like pretty much everyone starts, they try to learn some higher level languages like I don't know, Python or some language that it's really easy to understand. They are not really goes in the depth. Like what do you think, like for example, apart from this learning the logic and the main concept programming, like yeah, you have to start learning C and then you can learn other languages, but what do you think right now in industry, like most of the kind of businesses like are heavily depend on the C, that for example if I'm interested in, so C language is kind of important for me to understand and basically work doing my work. Like, do you have
It's
any specific fields for that, or?
Yeah, it's going to be mostly embedded where you have to write at that low level and you really need the control. I would like, based on the speed that I can write just hobby code, where I'm okay to write forever, make mistakes, it's fine. But I think if you want to write production code in a business environment where you don't have these very limited memory and hardware constraints, it's not the choice that you want to make.
Yeah. Yeah, I feel like it's more kind of learning purposes, and also maybe in some kind of scientific places like where this energy uses or so needed or something like that. It can be helpful.
Yeah, it can be really good for applied math if you're just doing like loop kind of stuff and you don't need a whole lot of special features. Sometimes it can actually be easier to write than Python because you can think about things in loops rather than the like vectorized math, which I find people have a really hard time grasping how you vectorize the math using NumPy and you just like put an addition here and suddenly all of the numbers are added. Whereas here, okay, you do have to get used to thinking in loops, but I find that easier to grasp by comparison.
All right. Thanks a lot. And I think we could wrap up here. I would like to thank Joseph again for you, like for this interesting topic. And I think that it will give also some directions to the people who are also starting the programming. And yeah, I also truly recommend everyone like to start first with a C language, understand, and then move to other languages. Yeah, guys, that was it. That was the end of DevStandup episode 20. And every week, like we feature one IT specialist from the industry. And if you would like to share your experience or know someone, you could contact us under the description below of this video. We have the link, and we could feature you and basically sharing the knowledge with other people across the world. So apart from that, I would like to thank again Joseph for his time, and I would like to see our next guest speaker in our next week. So yeah, thanks a lot and take care, guys. Bye bye.